Hi everyone, it's Days from Varnish Software. Welcome to a new episode of VMOD in the Spotlight. It's a video series where we highlight a specific module from the larger VMOD ecosystem, and in this month's episode we'll be looking at VMOD image. And as that name implies, we'll be handling images, more specifically converting JPEGs and PNGs that were sent by the origin into WebPs in Varnish. The conversion into WebP through VMOD image also allows us to control the quality of the image. We can do on-the-fly image resizing, and we can also enable lossless image compression. It is important to know that WebP is a format that was specifically invented for the web by Google, and it has both lossless and lossy capabilities. And on average, the image is 25 to 34% smaller than your regular PNG and your regular JPEG. And all these conversions happen on the edge, which means in Varnish. And the advantages of that are reducing the bandwidth in general. Smaller images means less bandwidth, less data over the wire, but it also means faster image loading at the client side. It also simplifies the image optimization workflow. If it's rather tough for you, given the software you have to convert JPEGs and PNGs into WebPs, we'll do that for you using VMOD image. And there's also dynamic optimizations possible based on client capabilities. If your client supports WebP, we'll give them the WebP. If your client doesn't support it, we'll present regular JPEG and PNG files. And we can also offload all of these conversions to the edge tier and consume the CPU there rather than doing it on the origin, which might already be overloaded. This is the image we're going to work with. It's a background image that is 2048 pixels by 986 pixels. And when we download it, when we transfer it via HTTP, it is 1.2 megabytes in size. And we'll write some VCL to optimize that and to turn that into WebP, which will be a lot smaller in size. Here's some VCL code to get started. The first thing we do is, of course, import the VMOD so that we have the image.webp function available. And then we're going to check the content type of the response that was sent by the origin. If the content type, which represents the MIME type of the content, is either image JPEG or image PNG, we're dealing with a compatible image that we can convert, and then we call image.webp to create that conversion and to store that version in the cache. This is the WebP version of the image that Varnish created. And this is the original PNG. If you pay close attention, and I'm going back and forth here, you can spot the difference. But since this is a background image, the nuances, the differences are so subtle that it doesn't really matter. And when we look at it from an HTTP point of view, the responses differ in two ways. The content length has changed and the content type has changed. And the content type went from image PNG into image WebP, and that was to be expected. But the content length, the change there is very significant. We went from a 1.2 megabyte image and turned that into a 57 kilobyte image. That's quite spectacular. And when we do the maths, that's 21 times smaller. That's definitely worth your while. And mind you, that's at 75% quality. When we change this from 75% into 50%, there's even bigger gains. And we control the quality by using a parameter called quality. By default, its value is set to 75. When we set it to 50, this is what we end up with. We're going from a 57 kilobyte image into a 42 kilobyte image. And this is what that looks like. This is our 75% quality level WebP. This is the 50%. There are changes, but they're really hard to spot. We can take it to the extreme and drop the quality from 50% to 0% and see what happens. Now, from a content length perspective, we're going from a 42 kilobyte image to a 10 kilobyte image, which is of course spectacular, but it has an impact. This is our 50% quality WebP. This is our 0% quality. The quality reduction is visible, and of course I wouldn't use the 0%. But it just goes to show that the default of 75% is quite generous, and even if we drop it lower, we can have an acceptable image quality. Up until this point, we've converted PNGs and JPEGs into WebPs without asking any questions, but we can do this process dynamically based on the capabilities of the clients. And here's an overview that I've got from caniuse.com/WebP that represents WebP support in the various versions of the most popular browsers. And we can see that there's a lot of support for WebP, but some versions don't support it or only partially support it. And we can take care of that, and we can cater to those needs. This is our original VCL code that we use to produce the WebP file. However, we'll add a bit more code just to be on the safe side. So the first thing we'll do is check whether or not the backend request, so the request that triggered the backend response, has an accept header that contains image/WebP. And when that is the case, we know the client supports WebP and we can produce the WebP image. However, we'll attach a vary header as well, containing the accept request header. This means we'll be creating cache variations based on the value of the accept header. If there's already a vary header, we'll just attach the accept value to it. And if there's none, well, we'll just produce a brand new vary header containing the accept request header. And here's an example of an accept request header sent by my personal browser, which is Chrome. It does contain image/WebP, so I'm safe and I can have the WebP version. But there's also a lot of other parts that might differ from browser to browser. And there's a risk of having too many variations. So we need to take back control and make sure we have the variations under control. And that's why we're writing some extra VCL. This piece of VCL code hooks into VCL receive, and that allows us to intercept incoming requests. And we'll do that to inspect the extension of the request URL file name. If it's PNG or JPG or JPEG, we know we're dealing with compatible images that can be converted into WebP. However, we first need to check the accept request header. And if that contains image/WebP, we know it's compatible. And just to make sure that we have tighter control over the variations, we actually turn it into image/WebP and remove all the other bells and whistles. However, when that image/WebP string is not found in the accept header, we're dealing with a browser that doesn't support it, so we turn the variation into image/asterisk. By using VMOD image, we're not restricting ourselves to just playing around with the quality level to reduce the size of the image over the wire. We can also dynamically resize it. Sometimes images are sent in too large dimensions and are resized in CSS. But what if we can do that already on the edge? That would allow us to have even smaller images. And we can do this using the same image.webp function, but by using a resize width or a resize height property. You can use both of them, but it's not really required. In the example you're about to see, we're only using the resize width because aspect ratios are maintained. So we're turning an image that was originally 2048 pixels in width into an image that is now 1024 pixels in width. Our image that was originally 57 kilobytes in size is now 23 kilobytes in size. And mind you, we didn't fiddle with the quality settings. It's still at the default of 75%. Before I end the video, I'd like to talk about the lossless capabilities of WebP. Throughout the video, we went with a standard quality level of 75%. We reduced it to 50, and even for fun and games, set it to 0. But we can also have a 0% quality loss. And we enable this by setting the lossless parameter to true. This doesn't reduce the quality, but just applies the regular WebP compression. And these are the results. Our original PNG file that was a 1.2 megabyte image was turned into a 994 kilobyte WebP image, which isn't all that bad. So in summary, you have lots of flexibility. You can fiddle about with the quality, you can resize the image on the fly, and you can even go for lossless compression. I believe that VMOD image is a solid foundation to build on to have more image conversion capabilities in the future. I'd like to thank you for watching, and I'll see you next month for yet another VMOD in the spotlight.